What's up guys, welcome back to Vanover Customs. In today's video we're continuing on with the Lathe project and we're focusing on the tailstock. We're going to be doing something that I've never seen done before and I'm super excited about it. We're going to be converting this single speed tailstock into a 2-speed tailstock. And the way we're going to be doing that is making our own custom gearbox and attaching it to the back and being able to give us a nice gear reduction here at the wheel. So let me get you in closer and show you what we got to do to make it happen. So this tailstock is designed very similar to most tailstocks that I've seen, whereas the back half is captured by this end bell, usually has a bearing or a bronze bushing in it, and then it has a screw that runs the entire length. That screw is allowed to free float with the wheel, and then it attaches to the quill via a fixed nut, meaning the nut is part of the quill, or a separate nut that is attached to the quill, and as you spin this, this free rotates, spins that shaft, and brings the quill in and out. So what we're going to do is we're going to remove this end bell and figure out a way to attach a rectangular style gearbox onto this flange, and we're going to make a new shaft that comes out a little bit farther that will house 2 gears, a larger gear and a smaller gear for the reduction. And then we're going to have another shaft on the bottom that has the same thing, a large gear and a small gear. And then on the front, we'll have a lever that engages a moving dog that will give us high and low range. I'm trying to keep the design of the gearbox as simple as possible to make it as easy to do as we can. So one of the things that's going to change to accommodate that is we're going to take this hand wheel and it will be moved down to the secondary shaft. So once we're done, this hand wheel will actually be down about 3 inches from where it is now. So that's kind of an overview of what I'm thinking in my mind. I don't have a drawing. We're doing this as we go, and we're just going to see what comes of it. So let's start taking this apart. Boom. We're on at 615 RPMs.
Time to come in here and do some threading. Let's go ahead and get this blued up with a Sharpie, and then we'll make our scratch pass. Well, that was a complete failure. We were able to make it halfway through, but the saw blade was smoked. I know this is 4130, but it's most likely hardened, which is why it's been a little bit difficult to machine. We weren't able to cut all the way through, and we ended up ruining a blade, so we're just gonna have to go and machine the rest of this off. See if we can get there that way. I apologize in advance, it's about to get really boring up in here. While we're here though, let me mention that I'm using a solid carbide boring bar, and these are very efficient at taking nice healthy cuts. I believe this is a 5/8 size boring bar, and we're using it over here on the blue lathe to take about 150 thousandths per pass. And again, this material is pretty hard, so we can come in here and make some healthy cuts at a pretty decent feed rate and try to be fairly efficient.
Well, we just got this part off the lathe and I could not be happier. The surface finish turned out really nice. It doesn't need to be, you're not gonna see it. It was a huge pain in the butt to machine and cut, but that does help create a better surface finish, and ultimately it's going to make this part a lot more durable because it's a really hard steel. The threads turned out really nice. Just to give you a brief idea of what's going on here, because we're building as we go, this is mimicking this back cap. So this back cap or end bell housed this thrust bearing. It dropped in there with both of these, so that will do the same. And then on the back, this just used a bushing for that support shaft, but what we're going to be doing is pushing in 2 bearings, which will offer more support and be smoother, mainly because we're going to have a gear locating right here, and I wanted more support for that shaft than just this. And then over here we have a plate. We're going to punch a hole, thread it for the 18 TPI 4-inch thread, and then fasten these together with the threads. And then from there, we'll get this mounted to the tailstock after modifying the tailstock, and then start continuing on with the gearbox. Now, I'm not going to show you doing this plate. It's real easy. I'm just going to fly cut at both sides, rip it to dimension, oversized dimension, because we're going to finalize it at the end. But I'm trying to keep this project moving along because there are going to be quite a bit of details. I just wanted to give you a little bit more airtime on making this piece because it is a little bit more unique and a little bit more complicated. So I'll bring you back once this is done. We'll join these together and I'll show you the modifications we need to make to the tailstock to kind of make our gearbox come to life. All right, we went ahead and got this plate knocked out off camera. We went ahead and made this a 4-inch 18 TPI thread pitch, so it threads on here real nice. We just have it mocked up so you can see the design come together. The gear is going to come up here and mount onto that tail shaft with the 2 bearing supports. And then instead of mounting this whole piece onto the end with these 2 taper pins, what we're going to do is actually drill and tap 4 holes into the tailstock for some beefy 9/16 bolts. And the reason that we're going to do that is it's going to allow us to have greater serviceability of this gearbox by being able to remove it from the end, and also it's going to be probably a little bit stronger than those taper pins. But before we do that, or in order to do that, we're going to take this over to the milling machine and we're going to machine off this back flange here. We have a nice little lip there. We're going to flatten it off, and then we'll go ahead and get them holes started. So let's go over to the milling machine and work on that next. All right, now that we got this back plate mounted and tapped, we're gonna come and clean up the edges, all 4 of them, with this brand new roughing end mill. So we're gonna get it started, touch off, come off the work, and come down and set them out. Well, we got this fresh off the milling machine and I couldn't be happier. This back plate and the adjacent piece there has been a lot of work, but I think it's completely worth it. Everything is fitting nice. We got all these holes tapped. Originally, we were gonna use 9/16 bolts, but we upped it to 5/8 because I made a mistake with the drill selection. Luckily, we caught it before I went to do any tapping, but I basically just looked at the chart wrong and picked the drill bit for the different pitch of 9/16. So we just stepped these up to 5/8 to remedy that. The head clearance is going to be a little tighter on the edge of the casing wall, but the extra bolt thickness should just give us some extra strength. So that turned out really well. You also saw us kind of come in here and machine all 3 sides. That's just going to allow us to have a nice square gearbox to build off of, and also have a really clean factory looking made up once we're done. We do need to come in here and sand both of these radiuses to match. And then once we get that done, we'll kind of extrude the gearbox off of this dimension. And then obviously we'll clean up here and then on the bottom as well. So off camera, I'm gonna come in here and just weld up some of this undercutting on this side mainly and plug up these holes. And then we'll grind and we'll fit this plate to these 2 radiuses. And then once that's done, I'll bring you back and then we'll start working on our pocket for our bearing for the lower shaft over in the milling machine. So I went ahead and ground this down and kind of blended it in, both on this radius and this radius over here, which you probably can't see. This is just going to be the limit of how wide and what shape our gearbox is going to be. You can do a lot of body work here to try to blend this in, and we will Bondo and fill this in. But the smoother the casting and the better the fit, the less thick we need to build up the Bondo, and it'll probably look better and be more durable. You probably can't tell, but there was a spot here in the casting where there was like a void. We went in there and we got it with the MIG welder. It's not perfect, and it doesn't need to be. I just didn't want a huge chunk of Bondo right at the corner, because at the corner is where something's likely to be less durable. So now it has metal and it's held in there. It has some inclusions, but again, doesn't matter. It's just gonna cut down on the amount of Bondo we gotta put there. And honestly, if you painted this just with a brush, it's good enough where it would completely disappear. So we really don't need to add a lot of filler. And now you can kind of see that the gearbox, if we do this right, is gonna fit this absolutely perfect, just like it was designed from the factory. So now we'll take this off, we'll get it over the mill and start to work on our bearing cap for the lower shaft and then go from there.
Here's a quick mock-up we made to test our gearing clearances. That way when we commit to making our holes, we know everything's gonna line up great.
guys, we made a mistake, and I'm gonna be honest about it. I made this plate too short. When I was thinking about the gears, I had a big gear here and a small gear here, and then it all of a sudden occurred to me that on the other side, I'm gonna have a large gear on the bottom as well, and without adding this piece, that large gear would hang out the bottom of the gearbox. So I could easily weld on a new piece, but because we're trying to avoid doing much welding on this project to keep everything flat and square, what I did is I drilled and tapped, and I have 2 dowel pins as well for alignment. So this piece is screwed on to the bottom, and then it was oversized on all dimensions, and then I came in here and machined it on the front and on the back, so it's in plane on all sides. So once we're done, it'll be no problem at all. This piece has no structural bearing, but believe me, it's plenty strong. It has 2 3/8 socket cap bolts. But yeah, you know, when you're doing something without a design, that's gonna happen. So the next step is to make the sides, the bottom and the top, and then the radius bits. I did my measurements, and we're gonna go with 4 1/4. So I'm just gonna cut a bunch of 4 1/4 inch plate, and they are gonna be welded together, but off of this, meaning separate. So that way, if there is any distortion, I can machine both faces and then bolt it or screw it back on to this and the back plate. So let's get to making those sides. Here's a better shot of the parts I was just working on, hopefully give you a little bit better visual reference. Now the gear that I chose, or the gear set, is the biggest gear set I could get given the dimensions. And based on the material thickness that I wanted to use, in order to accomplish that, the clearance is very tight. So we went ahead and machined clearance in here for the gear because it wouldn't clear with just the normal wall thickness. and then we had to machine clearance in here for the screws, because when we go to install this, we're going to put this cap on as one piece, and we need to be able to come in here from the back and get those screws in. So we could have went with a thinner wall thickness, and that's true, would have simplified things, but there are benefits to having the thicker wall thickness, mainly when I'm going to be screwing from the back. In some of these thicker sections, I can put my screws there, and then also in some of the corners where we need a little bit more meat to round off, I don't have to build up as much weld there by using a thicker joint of two metals. We're going to keep this box, you know, this will come up here as well, and the bottom piece, but we'll keep it separate from this. It'll warp, it'll do its stuff, that's fine. We'll machine these two faces, and if we need to, we'll clean up those faces so they fit nice on here. Then we'll get them bolted in place and then work the radiuses on the top. So this is kind of an idea of what we're going for.
We're over at the bench here. We're getting this welded out, and it may not be obvious, but the plan here is to get it lined up with the fireball squares. I get it tacked in position, and then I'm going to come in here and get everything welded. What you're not seeing is we're going to get everything welded in place, and then I'm going to come back and V everything out so that I can have some really nice thick weld ups, especially in the corners, because we're going to be shaping the corners or the radiuses, and I'm going to be grinding away like 80% of that corner joint. So I really want to make sure everything is properly V'd out and fully welded, so that way when I remove most of the material, I have a nice strong joint.
Well guys, I'm really happy with the way this gearbox is turning out. It is taking me a little longer than I expected. However, it is turning out better than I expected. This outer shell, which is one piece, is turning out really nice, and it just looks great. Again, a lot of the looks don't matter. What matters is the function, but to just be able to put our name on this and know that we did a really nice job makes me feel really good. In the part 2, we're going to be making a back plate. We're going to be putting the shafts in, making sure the gears are set up, creating a shift lever, and getting it installed back on the tailstock and getting it fine-tuned. So join me in part 2, and we will see you in the next one.